Hey, welcome to Zig for the Uninitiated. My name's Tyler. Let's get started. So in the last video, I talked about the saying I was going to talk about the arena allocator, but as I was doing research for that video, I realized that there's something important to talk about with regards to void, undefined, and null, in particular with undefined and how that works with allocators. And it's an important concept to understand once you get to using allocators a lot. And so I wanted to get into this and explain it. And I want to explain the differences between void, undefined, and null in this video. And I think this is a good thing to learn because I see this a lot in code, the example code from beginners and other people. There's a lot of mix up between these values, especially between undefined and null. So void, undefined, and null. Let's talk about what the differences are. Well, first is that void is a type, but undefined and null are values. So that might seem interesting, or I don't know, maybe esoteric, but it is an important thing to notice that a thing can be void, right? So a field can be void, but it doesn't take on the value of void, though there is in Zig a literal that you can use to describe the value of void, which is just two empty, the empty braces. That describes void. So whereas void is a type and undefined and null are values, what that means is that you can't assign, you can't type a variable as undefined. What you do is you give it a type and then say it has the value of undefined. So you could say, hey, here's my foo. It's a U8, but right now it's undefined. What that means is you're saying, hey, foo is a byte, but there's no real, not that there's no value there, but there's no meaningful value. No meaningful value. In fact, Zig documentation, I think, puts it the best. It says right here, undefined can be coerced to any type. Once this happens, it is no longer possible to detect that the value of undefined is undefined. Undefined means that the value could be anything, even something that is nonsense according to the type. Translated in English, undefined means not a meaningful value. Using this value would be a bug. The value will be unused or overwritten until before being used. And that's the key thing, is that when you say something's undefined, it's really just a placeholder. So it's uninitialized, and you're going to initialize it in parts. And so maybe with structs or something like that. Null, this is where I see a lot of confusion, is between undefined and null. Null is a well-defined value. Null means something. Null means that you have some object, let's say foo again, but its type is an optional U8. And then you say it's null. What you're saying is foo could be a U8 or null, right? It is an optional. So null is the non-existent case and then optional. Now, if you've come from languages like Rust or OCaml or other ones that have these kinds of ideas, I don't know actually if OCaml has it, but I know that Rust does. If you come from languages like Rust, where you have the idea of optional types, this will make sense. Just think of it as an option. But if you come from languages like Python or Go, where there is no difference between null and undefined, or rather that null means undefined, then it can be kind of confusing. But the way to think about it is null is a very nice value because it's a flag. It says, hey, it doesn't just mean that there's no data here. It means beats a well-defined way of saying the type of value that we want is not here. It's a nice way of being able to say this is either U8 or it's not. It's empty, right? You can either have something or nothing. Whereas undefined is a way of saying this value, is not initialized yet. And so undefined within the program doesn't mean anything, but without the program, it can be useful when you are trying to create an object. And so this is something I want to show you, because in particular with allocators, it comes up here. In here, I've got this function, or this code, the zig code, and we got this big struct. And let's say, right, we have big struct and it's 10, right? It's got an X and a Y, which X is a U size, Y is just an array of 8 U sizes. And by default, they should be 10, and this should just be array of 10. We can just change this to like, there we go. We'll just do that, okay? Just to make it fun. Now, what can happen here is, the important thing to remember is that allocation is not, I repeat, not initialization in Zig. Okay, in Go, that might be the case. In Go, they really stress this is very different than from languages like Go, where zero types are really stressed, that there's always some default, right? In Zig, it's the opposite. You could say, I don't know if opposite's the right word, but there's no like zero types. It's just allocation is not initialization. And I'll show you what that means here. So let's get our allocator. We're going to make a GPA. So we're going to do var GPA. Remember, the GPA is the concrete value that we want. And so we're going to do general purpose standard dot heap dot general purpose allocator. We're just going to go with the basic config. Just to know, I am still using 0.13.0. 0.14 is supposed to be coming out, and the way to create the general purpose allocator is changed there, the way to initialize it by the default initialization. So if you're watching this in the future, this is probably not how you're going to actually create the general purpose allocator. And I'll make a video about that later. Const. So now we want to make the allocator. So if you remember from the video about interfaces, usually we're not interfacing directly with, our general purpose allocator or our allocator, our concrete allocator. We're gonna go through the interface. Yeah. So what we can do here is create. So yeah, we're gonna do our my const my big struct equals, and we're gonna do allocator.create. So create is a function that you call an allocator to allocate one instance of an object. So we're gonna do a big struct here. This will give us a pointer to one big struct on the heap. You can see that. Oh, I gotta do remember that allocating is always a fallible process. You might not have all the memory, but deallocating is not. Okay, so we get this, it's, as I said, a pointer to a big struct. But if we look at this, it says returns a pointer to undefined memory. Okay, if I do print standard.debug.print this, and I print my big struct, and I build it, gonna build and run undefined, you will see there's a bunch of problems here. Like I'm getting, oh, you know what? I also I forgot to destroy it. So it's complaining about that. Defer allocator.destroy, which is the opposite of create my big struct. You got to give it the pointer. Okay. Now remember, the pointer is not undefined. The pointer is well defined. The pointer points to memory, but the memory itself is undefined. So if I rebuild this, there we go. Let's add a new line here so I can show through here. Okay, as you can see, all my variables are just these numbers. In fact, in release safe mode and in debug mode, Zig actually does set a value for things that are undefined. It sets it to hex, I think AA. In fact, you can just look, it's in the documentation. In debug mode, Zig writes 0xAA bytes to undefined memory. This is so you can help catch bugs. Okay, so you get 0xAA for undefined memory. That helps you catch your bugs. So these numbers are all the same, but if you're coming from another language, you might think, why isn't it initialized with all these values? I've told you, I've told the language I want these to be the default of big struct. And that's because allocators do not initialize data. Initializing data is a separate process from allocating data. And you don't want, Zig has chosen that those processes should not be together, or at least they should be somewhat orthogonal, that you should be able to create something without initializing it. Now, you say, well, what do I do then? If I, how do I get my big struct? What you can do here is my big struct dot star, which means, hey, I'm dereferencing it, because remember, my big struct's a pointer, so you can dereference it, and you just say big struct, you can just give it, this, and you're saying, this is how you can say, this is what I want the values to be. And if I rebuild this, oops, gotta rebuild it, rebuild, and then run, now you'll see that it's done correctly. Now, sometimes maybe you're okay with it being undefined because you're going to, eventually define it later in a different process. But particularly around creating objects is where I think this misconception or this error can happen a lot, because you think, oh, I've created this object and I've set this object to have defaults. It should have these defaults when I'm done. It will not have those defaults. Once you're done allocating, you need to then do the initialization. So must initialize after allocation. And you could do it by parts too. So, my big struct, you could have done it like this. You could do my big struct dot x dot star equals 50, and then, my big struct dot y dot star equals, we're just going to copy this one over here because I don't want to make something up. And if I rebuild that, it didn't like it. Cannot dereference non-pointer type usize. Oh, I put that in the wrong spot. There you go. Now you see like that. So there's different ways you can initialize. You could have provided some initialization, some static initialization function, fn init, that returns a big struct. And all you can do is just do return dot, and this is another way you could have initialized it. Do equals big struct dot init. And you'll get that. So there are a lot of ways you can do it, just depending on what the needs of your code or the needs of what you want to do it are done. Anyways, that's it for this video. Once again, if you got more questions, please do check out Ziggit. It's a forum for people who like to program in Zig, and there's a lot of good question answers. There's some documentation. I'm on there a lot, so you might see me, or I might defer to people who are smarter about Zig to answer your questions. But yeah, have a good one. Happy coding. Bye.